Hi and welcome to the first video of this new series where I will be teaching you guys how to use Etabs completely from scratch. The first thing we want to do is to create a new model and choose the settings we want to use in the model. We'll use built-in settings, Magic MKS will be the units, and the design codes stay the same. Let's click OK. Now we have to define the grid lines, and we can use uniform grid spacing or customize. For the example, we only use uniform. Let's choose two grid lines for each direction, and they will be spaced in the x direction 5 meters apart, and this one 7 meters apart. It will be a two-story building with a typical height of 3 meters, and a bottom story height of 3 meters as well. Let's click OK. Now the first thing we want to do, just to get rid of it and not have to change it later on, is to define the reinforcing bar sizes to be used. Let's clear this bar set and add a common bar set, which will be the US customary. That depends on the one you're used to using, but the one I think is the most common and the one I use is this one. Number 2, number 3, number 4, and so on bars. Let's click OK. Let's define now the material. We won't have to do that for this. We'll use this concrete 1400 psi. So let's go ahead and define the sections. Come here, add new property. Concrete beam will be the first element to be created. Let's call it beam B, and let's call 40 times 40 centimeters. That'll be 400 millimeters. This is the material, the one I said we would be using. The modifiers that we won't change for this video. And let's change the type of design would be the beam, the M3 design only, because the design for the column is different because it is designed to actual loads and moment in two directions. And also it works differently in Etabs. We'll see that in the end. So we'll use a rectangular configuration. It will be used as confinement bars, and the design will be the reinforcement. The cover will be 50 millimeters, 5 centimeters, 3 bars in each direction, number 8 bars, and number 3 for confinement bars. Click OK. Click OK. Now we'll make copy of that to make column. Let's define the column as column 50 times 50 centimeters. That'd be 500 millimeters. And we have to change the design tag to column. Well, it is already in column. I have to change the other one. I forgot to change it to beam. This one will be column. The cover will be 7 centimeters, and okay, that stays the same. Okay, now let's change the beam. And up beam. The cover 5 centimeters. Okay. Now we have to define the slab, which is the missing structural element. Slab section. Slab modify. We'll have a 140 millimeters slab, shell thick. The reason why I use this will be explained further in other videos, and we'll call it S 14 centimeters. Just click OK. And now let's place the structural elements created in the model. Let's use the beams first. Okay, to make it faster, we can go ahead and click in the option here. Sorry, let me delete this. We can come here, click on click on all stories, and that will change all stories at the same time. Okay, so place the beams, we'll go on, place the columns, the created sections, which is this one. You have to change the option here to this one, which is the column we've created. So place one in each corner. And to place the slab, we will choose here one story, choose this option, and the slab created. Second story and first story. We have to delete the one that was placed in the base. Okay, so right now we have to define the type of restraint of the structure. Let's go to the base, select everything, click on assign joint restraints, and we'll choose this one, the fixed one. Click OK. And right now we will create a combination, the load combinations. For the video, we'll only use this one, which will be 1.2 times the dead load plus 1.6 times the live load. 1.2 here, and we add another one, 1.6, name it live load. Click OK. Okay, so now let's assign the loads to each slab. Come here to the first story. Let's click in all stories. Select everything, click on assign. Click on shell loads, uniform. And for the dead load, we don't need anything because it has a multiplier of 1. You can confirm that here. Load patterns. We have the dead load with a self weight multiplier because that is the weight of the elements that will be the dead load. But for the live load, we have to choose the one to be used, which will be 500. Just live and OK. To confirm it was applied, we can right click here and we see in loads it was. It's okay. Now we can go ahead and run the analysis. Save it with a name, example 1. So I have it here. And after the structure is analyzed, we have to go ahead and click on the design option, reinforced concrete design. Okay, so one thing we have to do first is to select the design combinations for, and that will be the one we've created. So click OK. Run the analysis, can be done here or here outside. And here we can see, to see the if any element fails, we can come here, display design info, and go to the last option, identify all failures. Click OK. And there you can see that there are 2 beams failing. If we want to fix it, we just have to come here, analyze, unlock model, and change the size of those beams, increase them, or find any other solution. But that would be the procedure. So another thing we can do is another output is the moments that were generated by the program. We can come here to this option, combo, the one we want, and click here, moment. That will show us the moment of the beams. You can also see the actual forces of the columns. And that is everything for today's video. I try to make it short, just so it was just a video to get you familiar with the program. If you liked it, don't forget please to leave a like and subscribe for more content like this. And see you next time.